Hello everyone, welcome to this presentation. In this video, we are going to learn about hashing, an important concept in data structures that allows very fast data storage and retrieval. What is hashing? Hashing is a technique used to store and retrieve data very quickly. Instead of searching data element by element, hashing uses a hash function to calculate the address where the data is stored. This makes searching extremely efficient. Definition of hashing. Hashing is a method of mapping keys to values using a hash function. The data is stored in data structure called a hash table. Each key is converted into an index which directly points to the storage location. Basic terms in hashing. A hash function is a function that converts a key into a table index. For example, consider the hash function h of k equals to k mod 10. If the key is 25, then the index will be 25 mod 10, which is 5. So the data is stored at index 5. Steps in hashing. The general steps involved in hashing are as follows. First, take the key value. Next, apply the hash function to generate an index. Then, store the data at the index in hash table. For searching, apply the same hash function and directly access the data. The average time complexity of hashing is O of 1, which means constant time. Hash table representation. A hash table works similar to an array. Each index is calculated using a hash function. Because of this direct indexing, data can be accessed instantly without scanning the entire table. What is collision? A collision occurs when two different keys generate the same hash index. For example, h of 15 is 5 and h of 25 is also 5. Since both want to occupy the index 5, a collision occurs. Handling collision efficiently is a major challenge in hashing. Collision resolution techniques. There are two main techniques to handle collision in hashing. They are chaining and open addressing. Each technique resolves collision in a different way. Chaining steps. In chaining, multiple elements are stored at the same index using a linked list. First, compute the hash index. If the index is empty, insert the element. If a collision occurs, add the elements to the linked list at the index. Searching is done by traversing the chain. Chaining is easy to implement, but it requires extra memory. Then, open addressing. In open addressing, if a collision occurs, we search for another empty slot in the hash table. First, compute the hash index. If the index is occupied, find the next available location. Insert the element there. During searching, the same probing sequences follow. The main types of open addressing are linear probing, quadratic probing, and double hashing. Next, linear probing. In linear probing, when a collision occurs, we check the next index sequentially until an empty slot is found. The formula used is index equals h of k plus I modulo table size. This method is simple, but it can lead to a problem called clustering. Then, applications of hashing. Hashing is widely used in many real-world applications. It is used in database indexing, password storage, symbol tables, caching, and compiler design. Fast access time makes it ideal for real-time systems. Advantages and disadvantages of hashing. First, advantages of hashing include very fast data access, efficient searching, and a constant time complexity in the average case. Hashing is also widely used in real-time application. However, hashing has some disadvantages. That's all. Collision handling can be complex. A poor hash function reduces performance, and some techniques like chaining require extra memory. To conclude, hashing is a powerful technique that provides fast data access when implemented correctly. Understanding hash functions and collision resolution method is essential for designing efficient system. Thank you for watching.